Hello and welcome back. Now we've just finished implementing gravity, and thus far, gravity only works on our boring blue rectangle. Well, we'd like to start drawing things to the screen that are a little bit more interesting, like animated characters. So in this video, we're going to learn about 2D animation and how it requires the use of sprite sheets. Let's go ahead and get started. To understand sprite sheets, we first have to know what a sprite is. A sprite is a 2D image that gets drawn to the screen in a game. Each pixel on a sprite has its own color value, which means it has a red, a green, and a blue value, as well as an alpha. Now, alpha determines how transparent that pixel is. Now, since each pixel has its own alpha, we can have sprites that have transparent backgrounds, which allows us to draw Scarfy to the screen without a white square behind him. Now, a sprite sheet is one single image, and it contains multiple pictures. This saves us memory, and it also allows us to load a single file rather than several individual images. Whenever we draw Scarfy to the screen, we select part of the sprite sheet and only draw that part. So if we're animating Scarfy, then in a particular frame, we may be drawing one piece of the sprite sheet. And then when it's time to update the animation, we draw the next piece, then the next one, then the next one. And when we finally make it to the last one, we can start over at the very beginning of the sprite sheet. Raylib has a function that allows us to draw part of a sprite sheet. It's called draw texture rec, and rec is short for rectangle. So we're basically taking a rectangle from the sprite sheet. Draw texture rec takes 4 input parameters. The first is the texture. This is the sprite sheet image itself. Next is the source, which is a section of the sprite sheet designated by a rectangle. Next is the position, which is the location on the window where we want to draw our sprite. And finally, tint is the last parameter, which allows us to tint the sprite by a color. Let's talk about the first parameter, the texture. We first need to load the Scarfy texture if we're going to draw a part of the Scarfy sprite sheet. The next parameter, source, is a rectangle which we provide to specify which part of the sprite sheet we want to draw. Now, in this sprite sheet, we have 6 different Scarfy images. Let's say we want to draw the first one. Well, a rectangle is a specific type that contains its own properties. Rectangles have an X and a Y, as well as a width and a height. Now, when we pass a rectangle into draw texture rec, the X and Y refer to the position on the sprite sheet. Now, the sprite sheet itself has its own local coordinates, the top left corner being 0, 0. Now, the sprite sheet has its own width. We'll call that W. So if we want the width of a rectangle that only contains the first image of Scarfy, that's going to be W divided by 6 because we have 6 images of Scarfy on the sprite sheet. Now the sprite sheet has its own height. We'll call that H. So if we want a rectangle that gives us a cutout for the first Scarfy image, that rectangle will have an X and Y of 0 and a width of W divided by 6 and a height of H. Now let's say the time comes to update Scarfy's animation and we want the next Scarfy image in the sprite sheet. This means that the X of our rectangle needs to be updated. Well, if we're moving over to the next Scarfy image, then we're moving over by a length of W divided by 6. So the rectangle describing which piece of the sprite sheet to draw is going to be the same, except X will now be W divided by 6. Now, when we're ready to draw the next image of Scarfy, we're going to move the rectangle over again by W divided by 6, which means that X is now 2 times W divided by 6. Then, when we're ready to draw the next image, we move over by W divided by 6 again, and now X is 3 times W divided by 6. We're going to continue this pattern as we're drawing different sections from the sprite sheet. Now let's talk about the next parameter in Draw Texture Rec, which is the position. This is the location in the window where we want to draw our sprite. This position will be the upper left corner of the sprite, so here will be its position in the x and y coordinates. The next parameter, the tint, allows us to tint the sprite by a certain color, and if we don't want to tint the sprite, then we can just use white. So let's go ahead and set up our parameters that we're going to need to pass in to Draw Texture Rec. So we're back here in dasher.cpp, and we need to create some variables that we're going to pass in to our Draw Texture Rec function. Let's go all the way back up, and here just under gravity, I'm going to create a new variable, and this is going to be a texture 2D, and I'm going to call it Scarfy. Now, we're familiar with basic variable types such as int, float, boolean, and so on, but there are more complicated variable types, such as texture 2D. Texture 2D is a special type defined in the raylib library. Texture 2D is what's known as a compound data type, which has its own variables. We can access variables of a compound data type using the dot operator. We do it like this. We take the variable name, in our case Scarfy, and we hit the dot or the period, and this provides us with a pop-up showing us the variables that belong to the texture 2D type. So as soon as we declare a new variable of type texture 2D, we've created this compound type which has its own variables, such as height, width, and these other variables here. So how do we give a texture 2D an initial value? Well, I'm going to use the assignment operator, and I'm going to call a raylib function called loadTexture. LoadTexture takes a file path as an input parameter, and it goes to that file path and finds an image and loads that, and returns a value of type texture 2D. Now let's open the folder that contains our project. Remember, we pasted in this folder called textures, and if you look in textures, we have 5 different images which are .png files. Now because we're working in this workspace, Visual Studio Code will recognize the textures folder. So the file path to our texture is going to be textures/scarfy.png because this is the image we want to load. So for load texture, we're going to pass in the path. It needs to be in double quotes, and the path will be textures/scarfy.png. And now Scarfy will be initialized, and its own variables will have values now. Now, just like Texture 2D, Raylib has other special compound data types. Remember, Draw Texture Rec needs a rectangle describing which section of the sprite sheet to draw. Well, Raylib has a rectangle type. We're going to declare a new variable of type rectangle, and we'll call this ScarfyRec. Now, the Draw Texture Rec function also needs a position, and this position needs to be in the form of a vector2. Raylib has another special compound type called vector2, and we can create a variable of this type. We're going to call this one ScarfyPos for Scarfy position. So we've just learned about 3 new data types, all of which are special custom data types that exist in the Raylib library. And we saw that these have their own variables that we can access with the dot operator. So in summary, we've learned about sprites and how sprites are 2D images that contain red, blue, green, and alpha values for each pixel. This allows us to draw a character to the screen with a transparent background. We learned that we can use sprite sheets to load a single file that contains multiple images. We learned that Raylib has a Draw Texture Rec function which can draw a piece of a sprite sheet, and that this function requires some input parameters, some of which are of new types that belong to the Raylib library. We learned that the texture 2D, the rectangle, and the vector2 are compound data types which contain their own variables. And we initialized a texture 2D using the load texture function, which took a file path to an image in our textures folder, In the next video, we're going to work on calling the drawTextureRect function and passing in some of these new variables that we've created. I'll see you in the next video.